So as stated on the title of this sheet, it says inelastic collision. So yes, this video has something to do about inelastic collision. Previously, in the last video, we have the total momentum before collision is the same or conserved, or they're same compared to after collision happened in terms of its momentum. So inelastic collision or elastic collision, both of them would have the same momentum. Okay, so would have the same total momentum, just to be exact. The only difference is that the total kinetic energy before collision will not be the same anymore, unlike the inelastic collision. Total kinetic after. The reason why they're not the same because this time two objects touch each other. So for example, as they touch each other after collision, or when they collide, as the actual collision happened, okay, so during the actual collision, those two cars or objects have touched each other. Because they have touched each other, vibration, okay, so there is vibration, okay, because they collide with each other, we produce vibration. So vibration is a form of energy. Okay, vibration is a form of energy, which leads to thermal energy. Okay, thermal energy. Second, as they touch each other, there is sound. There is also vibration, and that vibration is converted to sound energy. So therefore, because there is the presence of vibration, some of the kinetic energy is converted to thermal energy and sound energy. That's why there is what we call losses of kinetic energy. But the total energy will still be the same. It's just so happened that it's not all kinetic energy anymore. So it's just the kinetic energy that is not balanced. Okay, so it's not balanced. So here in this question, we have two railroad cars. Okay, two railroad cars. First one, just like what I mentioned earlier, usually the first one we use the uppercase, not because the first object is bigger, and assuming that this railroad is not, okay, so it's not inclined, so it should be a straight line, level. Okay, so level track. Okay, so level. Okay, so level track. According to the problem, the mass of the first object is 2,000 kilograms. The velocity is at 5 meters per second. Initial velocity of this first object is 5 meters per second. 5 meters per second. And of course, it's going to the right. Okay, it's going to the right. And it will hit the object or the other railroad cart with a mass of 6,000. Some of you might say, why did you use lowercase for 6,000? Well, you can do it if you want, but just for the uniformity, I'm using uppercase for the first object on the left side and lowercase on the right side, instead of using subscripts. So V sub I is 0 because it starts at rest. Now, according to the problem, if the cars coupled together, so when you hear or when you see the word coupled, coupled means they got connected to each other. So if I have this 2,000 kilogram cart, okay, 2,000 kilogram cart, and now it's still moving to the right. Okay, it's still moving to the right, which is V sub F. And it is connected. So it means that these two carts got connected to each other. So they're not separated. So they're moving together. Okay. So coupled, another word that you might see in the problem, connect. Okay. Coupled, connect. And this means that they do mean something in terms of one of those values that we need to consider. So this one is 6,000 kilograms. Now we have the velocity v sub f. So they're moving in the same direction, and at the same time, just because they're connected to each other, when you see this word coupled or connected, these two velocities are the same. So it means you're moving at the same speed. Okay? It's the same speed. As I always use an example, when two people are walking together hand in hand, you need to have the same speed, or else if one is moving faster and the other one is moving slower, you are dragging one another. At the same time, if one is going to the right and the other one's going to the left, or forward or backward, you are pulling each other. Okay, you're pulling each other, the other one's dragging each other, different speed, pulling each other because you have different direction. So in this case, since we have the same velocity, we'll just use letter V. Okay, I'm just going to say that since they're the same, just use V. They do have the same velocity. So let's start with before. Okay, so let's start with before. So our mass multiplied by V sub I, lowercase mass V sub I. So this one will give us 2,000 times velocity of 5, and this one is 6,000 multiplied by 0. Definitely this will give us 10,000 kilogram meters per second, and this one is 0. If you add those two numbers together, this is our total momentum before, which is equivalent to 10,000 kilogram meters per second. Now, in terms of the situation that we have here, where both of them got connected, very simple. Now this time, we will use M. Instead of using V sub F, since they're the same, let's just use V. And this one is lowercase multiplied by V. So this will give us 2,000 times V, and this is 6,000 times V. So if we take the sum, if we add those two numbers together, which is the product of mass and velocity, that is still our momentum after collision. But we are expressing our answer in terms of V. So 2,000 plus 6,000, that will give us 8,000 V. 8,000 V. Now, all we have to do here is to equate. Okay, so let us equate those two numbers together. Then we can say, let me just use a different color. While equating those two together, so they should be the same, equal to each other. So 1 or 10,000 is simply equivalent to 8,000 V. Cancel those zeros. So this will give us 10 divided by 8 equals your velocity. Then we can say immediately that your velocity is simply 1.25, because that's 1 1/4 meters per second. Okay, so this will be our velocity. Now, in case you want to figure out if it's really true, okay, it's really true that this is inelastic. This is an example of inelastic. Why don't we check our data? and that is the total energy, total momentum should be the same as the total momentum after. Let's plug in the values, and then at the same time the kinetic energy is not the same before and after the collision. So as we are going to look at this information, the total momentum before, just using this information, so the total momentum before is already provided to us, and that is 10,000 kilogram meters per second. How about our total after? So total momentum after collision, by using this equation right here, which is 8,000 times V. And from our solution, 8,000 is V is 1.25 meters per second. 1.25 meters per second. So what is this value right here? Is it 10,000? Just for the sake of showing if it's really 8,000, why don't we do it? Yes, it's 10,000, of course. 8,000. Okay, 8,000 multiplied by 1.25, so that's 10,000 kilogram meters per second. So it means that the first condition is already satisfied. Okay, so first condition is already satisfied. Now let's take a look at the kinetic energy. So in the kinetic energy aspect, kinetic energy. Okay, so let's talk about before. That is 1/2 m v sub I squared, which is 1/2 multiplied by 2,000 times the square of 5 meters per second. And then the other one's 1/2, which is the easiest one because there's no velocity, so any number multiplied by 0 is 0. So let's figure out the value, which is 25 times 1,000, which is 25,000 joules. Why is it multiplied by 1,000? Because 2,000 divided by 1, so that's 1,000 times 25. That is 25,000 joules in terms of energy. And 0. So the total kinetic energy before collision, okay, kinetic energy, total K before collision is 25,000 joules. So this is before. Now let's solve for the total after collision. So let me just use a different color ink. So this time I have 1/2 mass v sub f squared, and we all know that they do have the same velocity, by the way. So that will give us 2,000 times 1.25 squared, and the other one is 1/2 mvf squared, which is also the same as 1/2 6,000 times 1.25 squared. Let's just simplify it. 1.25 square, 1,000. So that will give us 1562.5 joules, while the other one is 1.25 squared times 3,000, and that is 4,000. Let me just double check. 1.25 squared times 3,000. So 4,687.5 joules. So if we add those numbers together, let us compare. It's total after kinetic energy after. They shouldn't be the same. Plus 1,562.5. So this will give us an answer of 6,250 joules. So we all know that this is less than 25,000. So yes, since 25,000 joules is not equal to 6,250 joules, therefore collision is inelastic as it's shown. Okay. Hope that in this video, despite having additional information, so solving that we added in the problem, it also covers more information that we need in the future as we tackle additional problems in the future related to law of conservation and momentum.